Introduction. Hello everyone, and welcome back to our channel. Today, we're diving into a topic that is crucial for anyone interested in artificial intelligence and machine learning: building a scalable AI model deployment pipeline, from development to production. In today's fast-paced tech landscape, developing a robust AI model is only half the battle. The other half is ensuring that model can be deployed and scaled effectively. So, whether you're a seasoned AI engineer or just getting started, grab a notepad and let's get into the nitty-gritty of building a deployment pipeline that can grow with your needs. Understanding AI model deployment. Before we tackle the specifics of building a deployment pipeline, let's first clarify what we mean by AI model deployment. Essentially, deployment is the process of integrating an AI model into an existing production environment so that it can make predictions and provide insights based on real-world data. This phase can be incredibly complex because it involves not just placing the model into production but also ensuring it runs efficiently, scales as needed, and integrates seamlessly with other systems. The goal of a scalable deployment pipeline is to allow for continuous integration and continuous deployment, often abbreviated as CI/CD. This means that whenever a new model is trained or an existing model is updated, these changes can be pushed into production quickly and reliably, without causing significant downtime or disruption. The importance of a scalable pipeline. Why is scalability so vital? Well, AI models often undergo iterations based on new data, changing business needs, or improved algorithms. A scalable deployment pipeline enables organizations to adapt quickly to these changes. As the volume of data increases, the pipeline should be able to handle larger requests without a hitch. If your deployment pipeline is not scalable, you risk delays in delivering updates, increased operational costs, and, most critically, the potential loss of business opportunities. Step 1: Establishing infrastructure. The first step in building a scalable AI model deployment pipeline is to establish the necessary infrastructure. This typically involves cloud services, on-premises systems, or a hybrid approach. Public cloud platforms like AWS, Google Cloud, and Azure offer scalable computing resources that you can configure to fit your needs. They provide services like container orchestration with Kubernetes, serverless computing options, and managed databases that are essential for running AI workloads. When selecting your infrastructure, consider the following factors: performance, scalability, cost, and the specific requirements of your AI models. It's also important to ensure that your infrastructure can handle various data types and processing workloads, since AI models may require different resources based on their complexity and the size of the datasets they handle. Step 2: Data management. Once you have your infrastructure in place, the next step is data management. Data is the lifeblood of any AI model, and how you handle it will significantly impact your deployment pipeline scalability. You'll need robust solutions for data storage, data processing, and data governance. Start by setting up a data lake or a warehouse where you can store both structured and unstructured data. Data lakes are particularly useful for AI projects because they allow you to store vast amounts of raw data until it is needed. Next, implement data preprocessing pipelines to clean and transform your data into a format suitable for training your AI models. This is where tools like Apache Spark or TensorFlow data validation come into play. Don't forget about data governance. As your pipeline scales, ensure that you have policies in place for data access, security, and compliance. This is especially important if you're dealing with sensitive data, such as personally identifiable information or health records. Step 3: Model training and versioning. Moving on to the core of the deployment pipeline: model training. It's essential to have a consistent and efficient model training process. Use tools that facilitate automated training, like MLflow or TFX, TensorFlow Extended. These tools allow you to automate the training process and keep track of different model versions. Model versioning is critical in a production environment. As you update your models, you'll need a way to manage different versions and revert back if a new model doesn't perform as expected. Integrated version control systems, like DVC, data version control, can be handy for tracking changes in both datasets and model parameters. Implementing automated testing for your models after training is also crucial. Unit tests and integration tests can help ensure that your model performs correctly and meets the specified requirements before deployment. Step 4: Containerization. Once your model is trained and tested, the next step is to prepare it for deployment. Containerization has become one of the best practices for deploying AI models. Using technologies like Docker, you can package your model along with its dependencies in a standardized unit called a container. This ensures that your model will run consistently regardless of the environment it's deployed in. Containers also simplify scaling. For example, if you're using Kubernetes, you can easily replicate the containerized model across multiple nodes, adapting to increased load by adjusting the number of replicas. This horizontal scaling capability is crucial for high availability applications where you cannot afford downtime. Step 5. API development. After containerization comes API development. An API, or Application Programming Interface, is critical for allowing other services or applications to communicate with your AI model. RESTful APIs are commonly used because they're simple and widely supported. When designing your API, consider how it will handle requests and responses, including error handling and logging. Ensure that your API can scale as needed and manage incoming requests efficiently. Tools like Flask or FastAPI are popular in the Python community for developing lightweight APIs quickly. It's also a good idea to implement rate limiting and authentication to ensure that your API can handle traffic without becoming overloaded or vulnerable to attacks. Step 6. Monitoring and logging. Once your model is running in production, monitoring and logging come into play. Monitoring helps you keep track of your model's performance over time, ensuring that it continues to deliver accurate results. Implement tools like Prometheus or Grafana for real-time monitoring and alerting. Logging is equally important for diagnosing issues and understanding how your model performs under various conditions. Store logs in a centralized system such as ELK-Stack, Elasticsearch, Logstash, and Kibana, or use cloud-based solutions like AWS CloudWatch. Collect metrics related to model performance, such as latency, accuracy, and the volume of requests. By establishing a feedback loop, you can quickly identify when the model's performance begins to drift and take corrective actions as necessary. Step 7. Continuous integration and deployment. Finally, to truly build a scalable deployment pipeline, you need to implement continuous integration and continuous deployment practices. This means automating the testing and deployment processes so that any changes made to the model or codebase can be pushed to production with minimal manual intervention. Set up a CI/CD toolchain using platforms like Jenkins, CircleCI, or GitHub Actions. These tools allow you to automatically trigger tests whenever new code is pushed, and if everything passes, deploy the changes seamlessly. This greatly reduces the time it takes to get new features into the hands of users and ensures that your AI model stays current. Conclusion. So, there you have it, a comprehensive guide to building a scalable AI model deployment pipeline from development to production. To summarize, we started with the importance of having a solid infrastructure, moved on to data management, model training and versioning, containerization, API development, monitoring and logging, and finally, implementing CI/CD practices. In today's world, where agility and responsiveness are key, having an effective deployment pipeline can set you apart and allow your organization to harness the full potential of AI. Remember that building a scalable deployment pipeline is not a one-time effort, it requires continuous improvement and adaptation as technology and business needs evolve. If you found this video helpful, don't forget to like, subscribe, and hit that notification bell so you never miss an update. We'll be covering more exciting topics related to AI, machine learning, and data science in the coming weeks. Thanks for watching, and we'll see you next time.